All right, great. Let's talk a little bit more about the borda. That's what we were doing at the end last time. I just want to do one more example just to refresh our memory, and then we'll talk about something else. So the borda is our fourth of our ranked voting methods, and I'm going to try the borda. This will be kind of the biggest and most complicated borda that we ever do. This is an example that we've actually done several times. So you probably have this specific example written down in your notes at least 3 other times. This will be the last time we look at it. You missed the super big announcement, but I'm not telling now. You'll have to ask somebody else or watch the video, I suppose. I'll tell you later if you are interested. It is about the exam, no spoilers. Yes, it's about the exam. You'll just have to wonder for the next 46 minutes. Okay, this is the exam example, not the exam. I want to do the borda on this. I hope you all remember how the borda works. That's the one where you add up the points. So the points, remember, last place gets you 0, and then it sort of goes up from there. These are the points for each position. And we have to add up all the points, being sure to multiply when appropriate. So like, for example, the points, let's add up the points for A first. What are the points for A? Well, in this spot right here, this vote for A gets 3 points, but there are 14 people who voted in that way, so that's going to be 14 times 3. Those are the points that A gets from that first column. 3 points each because they're in the top position, but there were 14 of those votes, so it's 14 times 3. In the next column, here we have 10 voters gave 0 points each. And actually, I can see all of the other votes will earn 0 points for A. So I suppose that is A's total, just 14 times 3. But just for the sake of being clear about everything, it's also 10 times 0, and 8 times 0, and 4 times 0, and 1 times 0, right? Those are the points from all the other columns. But anyway, those are all zeros. So really it's just 14 times 3, which is 42. All right, that's the total for A. I did these numbers ahead of time on my calculator. That I think is not so hard to do. Some of these are easy to mess up if you're doing it in your head. I hope everybody's clear on the method. Let's try the points for B. So I'm looking at where the various B's go. So here's a B. B gets 2 points in this position, but there's 14 of them, so that's 14 times 2. Each time I'm just multiplying the number at the top of the column times the point value in whatever the position is. So the next column over, the number at the top is 10. I go 10 times, this position is where B is, that's 2 points, so it's 10 times 2 here. Next over, I go 8 times 1, that's because this is a 8 column and 1 point each for the B here. Next over, I go 4 times 3, because this is 4 voters, 3 points each. And finally, it's going to be a 1 times a 1. All right. And I did these multiplications. Remember, when you're doing these on your calculator or something, you have to multiply first and then add them all up. I get 69 for the B. Multiply first and then add. All right. This is how we do it. So C gets 14 times 1. That's because C is in the 1 point position in the first column. Next column is 10 on the top. This time C gets 3 points from those guys. Next is 8 times 2. That's this one right here. 8 voters, 2 points each. Next is here, 4 voters of 1 point each, so that's a 4 times 1. And then the last column, C, is up top, 3 points, 1 voter, 1 times 3. This one I added up, I got 67. And then finally, the D's. I hope everybody is clear on what's going on here. 14 times 0. The next one will be a 10 times 1, and then an 8 times 3, and then a 4 times 2, and then a 1 times 2. And these add up to 44. Anybody got questions about how we did the numbers? Yes?
Are you also allowed to write it like, for example, B 4 times 2, 14 times 2? You can also just write 28.
Yeah, sure. Yeah, you can do any parts of this you can do in your head if you want to. Yeah, I'm trying to make it clear exactly where all this comes from, but if you're doing this on your own, feel free to write it differently if you prefer. Okay, and anyway, B is the winner, right? That's the most points. So B wins with the Borda. All right. I said before that we actually have done this same example many times. Then maybe I'll just refresh our memory. So this same example, if you look back in your notes, you will see. If we did plurality, then A was the winner. If we did the rank choice, then C was the winner. D. If we did the Condorcet, then C was the winner. And if we did the Borda, then B was the winner. So in this particular example, choosing a different voting method gets you a different winner every time. And the natural sort of question to ponder is like, okay, fine, who's like the real winner though? And the answer is, what do you mean real? There is no real winner. These are just 4 different ways that you could judge the election. And I would say, none of these are like obviously the right way or the true way to do it. They are just different ways to do it. And they give you 4 different answers. So the big moral of the story is, I would say it this way, different reasonable systems can give different winners. Right? And this is how I would describe, like, if I was, talking to somebody in the club about the mathematics of voting, like, why is that interesting? I would say it's interesting because there are different natural seeming ways that you could try to add up the things and figure out who the winner is. And they'll all give you different answers. Even though, like, it's not like I'm getting different answers because I did it wrong or because one of these methods is just totally absurd. In my opinion, none of these are totally absurd. They just give you different answers. And it's an interesting question about, like, what are we really supposed to do in real life? Which one of these is better than any of the other ones? And the answer is kind of like, well, there isn't one that's like the best one, or at least that's there's no obviously better one or obviously worse ones. All right? I've said in the past, I kind of like the rank choice. And I kind of don't like the plurality just because I feel like the plurality ignores a lot of the preferences of the voters, and the rank choice doesn't. But there are problems with all of them. All right? Any thoughts about that? I think that this is interesting. I hope that you think it's a little interesting, just the fact that there are different reasonable methods, but they all give you different answers. All right? Okay. What I would like to discuss next is, I want to talk at least a little bit about this question of, like, which one is the best then? If there's different ones and they give you different answers, of course in real life we have to choose something, right? Unless you are a democracy hater. Like, I would say one conclusion to this whole realization, if different systems give you different answers, maybe we just shouldn't do it this way. Maybe we shouldn't vote at all or something, which to me this is not a good conclusion. Like, my own opinion as a citizen of the land of the free, but also a mathematician, is like, I actually do believe in democracy, and I think that voting is the way that we should decide things. But at the same time, I also understand that there are different ways of voting, and it's worth thinking about which is better than the other. So which of these are better versus worse, I guess, is the question I want to ask. And again, the answer to this question is not simple. I would say the only sensible answer to this question is, what do you mean by better? And you have to talk about, like, specifically, how would you even say this one is better than this one? I think there's one of these which we have already discussed is not really appropriate for use in the real world for a very fundamental reason. Anybody recall? One of those four actually people do not use in real life, and there's a reason why. Anybody remember? Yes, it's the Condorcet, and why don't we do that in real life? Yeah, because sometimes there is no winner, or like the Condorcet doesn't always choose a specific winner, even in an election with, like millions of votes. Sometimes it just sort of like comes out as a tie. So in that sense, the Condorcet is kind of worse than the other three, but between the other three at least, how can we decide which of them are better or worse? And I will say there are actually many different mathematical ways to analyze these. I'm going to say mathematical criteria for evaluating which of these are good and bad in various ways. There are many different ways that you could try to evaluate these. There are many different mathematical criteria for evaluating which of these are good and bad in various different ways. And we're going to talk about just one of them. What I would like to discuss is what is called the majority winner criterion. This is the singular of a criteria. So this is one specific way that you could look at these various systems and try to determine if they are fair or not. All right? Like I said, there are many other ways that you could try to look at these systems and try to decide if they're fair or not. Here I have another bit of an announcement, I suppose. In the past, when I taught this course, like I taught this course last year, and I believe when I taught it last year, we actually talked about 4 different criteria for deciding whether various methods are fair or not. I decided this time around to cut it down to only this one, but on the big list, the checklist of the topics, which I copy pasted from last semester, I messed it up. I left on the wrong one. So if you have your list, I hope that you have your list. This right here, I wrote this one. I don't want to talk about this one actually. I want to talk about what I just wrote, the majority winner criterion. So do a little one of these. Sorry about this. The majority winner criterion. We are actually not going to talk about what he used to say, the Condorcet winner criterion. That's another thing. It's not all that complicated, but I wanted to. I had 3 other things here that I took out, and I inserted some more stuff further down the list. So we are going to talk about the majority winner criterion. Sorry to change the list of topics on you. It was a typo. If you don't have your list with you and you're unclear about what I just said, feel free to ask me again in the future. Okay, so we are going to talk about the majority winner criterion. Remember, this is meant to be one specific way that you could look at these different systems and try to judge which ones are fair versus which ones are not fair. So this is one specific way to judge fairness of a system. And it has to do with, based on this kind of idea of majority rule, right? People often casually say that, like, the great thing about democracy is you get majority rule. But although, like I've said several times, in our system that we use, actually you don't get necessarily majority votes when you run elections. You know, the winner might win with like 49% of the vote, which is not a majority. Majority means more than 50%. But anyway, one specific way to judge fairness based on the concept of a majority rule. And the idea here is, okay, we all know when people vote, you don't always get somebody who goes over 50%. But I think we should all agree, certainly if somebody really does go over 50%, then they ought to be the winner of the election. So that's the idea behind the majority winner criterion. It says, so I'm going to write this again. This is the majority winner criterion. It says, if one candidate is ranked in first place by a majority of the voters, and remember, majority means greater than 50%. It doesn't mean more than everybody else. Yeah, majority actually means more than 50%. So if one candidate is ranked in first place by a majority of voters, then that candidate should win the election. All right, this is called the majority winner criterion. And this is one specific thing that you can say about fair methods. And now we can ask ourselves, okay, is this actually true if you use the plurality system? Does this actually hold out using the plurality system? Is it really true if somebody gets more than 50% of the votes, they are going to be the winner? Does this automatically hold true in the ranked choice? Does this automatically hold true in the Borda? So the question is, which of our systems actually behaves according to that statement right there? All right? This is a desirable thing that you would want to be true of whatever system you're using. And now we can ask which of our systems, we have 4 of them, right? The plurality, the ranked choice, the Condorcet, and the Borda. Which of our systems actually, the way we would say this is, obey this criterion? All right? And then this would be one specific way that we could try to measure, is this one better than this one, right? So this is what I would like to discuss. The majority criterion is a desirable property. I hope everybody agrees with that. Like in a normal democracy, you kind of would want this to be true. This is how things are supposed to work. If there is actually somebody who a majority of the voters think is the best, they should probably win the election. All right. The question is, which of our systems actually do obey this? So. Let's talk first of all about the plurality system. Well, let's talk about, does the plurality obey the majority winner criterion? I hope you don't mind my little abbreviations. This is majority. Anybody have thoughts about this? So remember the way that the plurality system works is whoever gets the most amount of first place votes is the winner of the election. Is it actually true that if somebody really does get more than 50%, then they will win the election if you're doing the plurality? Any thoughts about that? Yeah?
Only if there's 2 candidates, and if there's more than 2 candidates, it's possible that the winner has less than 50%.
Yes, that's right. If there's more than 2 candidates, it's possible to win with less than 50%. Although the majority criterion is kind of the other way around. You imagine, first of all, if somebody really does have more than 50%, does that mean they're going to be the winner? So there's another question. Do you have to get 50% to win? The answer is no, not in the plurality system. But the other way around is what I'm really trying to think about. If you do get more than 50%, does that mean you're automatically going to win? Is this a stupid question? I see some people nodding their heads. It is true. In the plurality system, if you really do get more than 50% of the votes, then you're gonna be the winner, That's because, remember, how we decide the plurality system is, in order to be the winner, you have to get more than everybody else, right? But if you get more than 50%, then automatically you get more than anybody else got, because it's not possible for two people to get more than 50%. So I'm going to try and write down, the answer here is yes. Yes. I'm going to try and write down in some amount of specificity. Let's try and be a little explicit about this. So I'm going to write this as a little argument here. So plurality, and I'm going to ask you to write some very short little logical arguments like this on your homeworks and on the tests. Plurality does satisfy the majority criterion, the majority winner criterion. And I'm going to prove this for you. Proof. All right. Now, this is not going to be a long-winded logical argument here. And really, every time you do this for, I want to talk about this about not only plurality, but the other systems also. Every time you do this, the proof that you're going to write, which I'm going to ask you to write, will have the same kind of structure. All right. Here's how the proof must go. I'm going to begin like this. Let's say, imagine that, let's say, candidate X gets more than 50% of, well, can I say this differently? Sorry. I want to say X is, really I need to say is ranked in the top position by more than 50%. Sorry to erase here. Imagine that X is ranked first by more than 50% of the voters, right? Now we have to explain why this means that X must be the winner. So I'm gonna say some stuff here. I'm just gonna give you the structure of what I'm saying. Something, something, something. Probably this will only take like one sentence or so. And then my conclusion will be, thus X is the winner using the plurality system. All right? Oftentimes these little proofs, it can be hard to think about like what are the logical steps that I'm supposed to be writing. But having this basic structure, I find, is helpful. If you're trying to explain why somebody is some system satisfies the majority criterion, you always begin by saying, let's pretend we had somebody who really was ranked in the first place by 50%, more than 50% of the voters. And then you got to say some stuff, and you conclude that X is the winner using the plurality system. Anybody want to suggest what we can say in the middle here? So now you actually have to think about something. This, you can, if you do enough of these arguments, you will know how to structure the logic here. I think you can just say maybe like one sentence in the middle, which will tie it all together. If somebody is ranked in the first place by more than 50% of the voters, how do you know that person's going to win using the plurality system? Anyone think you can say it? Yeah?
And it's not possible for any other choice to have more.
Yeah, right. She said, if they're ranked first by more than 50% of the voters, it's not possible for anybody else to have more rankings than in the first place than that, because if you get more than 50%, then nobody else can get more than 50%. So you got to say something like that in the middle here. Can I just, maybe I'll say it this way, then there are, of course, many ways you could write this, and you don't have to say it exactly like I do, but I will say something like, then X gets more first place rankings than anybody else. Right? That's automatically true. If they get more than 50% of the votes, nobody else can get more than that, because it's not possible to have two different people getting more than 50% of the votes. All right? Then X gets more first place rankings than anybody else. Thus, X is the winner using plurality, because that's what the plurality is all about. You count up how many first place rankings each person gets. That's how we do plurality. That's what the plurality is. All right. This kind of thing is what the sort of homework and test questions concerning the majority criterion will look kind of like this. I will ask you to write down a very short proof, I suppose. I mean, it's really just the structure of it will always be the same. It's really just the middle part that you'll need to fill in. Any questions about this? Some people ask me about, like, can't we just like do math again? Maybe some people prefer just like adding and multiplying numbers. My response is, this is math, son. This kind of logical reasoning, like, that's math. Just adding and multiplying numbers is like accounting or something. I mean, yeah, that's math too, but that's not really the true math. All right. Can we do the same thing for the Condorcet method? So I would like for you all to try this. I want you to demonstrate or explain why. In fact, the Condorcet method also does satisfy the majority winner criterion. So you do Condorcet's method. All right. That is, I want you to write a similar proof that explains why the Condorcet method satisfies the majority criterion. The only difference really is the part in the middle, right? The rest of the structure should be the same, although at the end you shouldn't use the word plurality. You should say, thus X is the winner using Condorcet's method. All right? I'll give you a few moments to think about it. Without thinking, you should be able to write the beginning and the end of the proof. It's really, the only part you have to think about is this thing in the middle.
Sorry, what was the question again? I forgot.
So you have to write a similar proof, but about the Condorcet method instead of the pluralities system. I'm going to get started the structure. So
Yeah. About
explain better than that. Yeah, that's right. What you got? This is pretty big. You guys getting anywhere? This is true, but not really relevant. You have to think about what does it take to mean so you have to think a little bit about how the conversation method works and what does it take to
I don't know why I meant like a pair. Could you read mine again? Or, I'm fine. Do I even count this?
No.
It's like,
You don't actually.
yeah, that's what
Just wins all its comparisons.
Yeah.
Yeah, remember the conversation method is about so if it's really true that someone's right, I think that means it's automatically and so that's right. You gotta say something like that. All right, can we talk about these? Because we gotta go a little bit soon, and I wanted to say one more thing. As I was walking around, I saw a lot of great answers here. Really, what you write here has to say something about pairwise comparisons, because that's what the Condorcet method is all about. If you wrote something here that doesn't mention the comparisons, then it can't be right what you're saying. You need to be saying something specific about Condorcet's method. And why is it, if someone is ranked first place by a majority of the voters, why are they going to win the Condorcet method? The answer is, it's because if they're ranked first place by a majority of voters, they must automatically win all of their individual comparisons. And that's why they win using the Condorcet method. So how I would write that, as I was walking around, nobody wrote this exactly the same way, and that's totally fine. I would just say, then X wins all their pairwise comparisons. I think that's really all you need to say. And thus X is the winner using the Condorcet method. All right? I don't think anybody said exactly those words, but you had to say something about pairwise comparisons. If you were not saying something about pairwise comparisons, it means you weren't talking specifically about Condorcet's method. Yeah?
Did you say pairs? Like
Pairs,
really
sure.
More pairs than anyone else?
Yeah, sure. Yeah. Or you could say head-to-head matchups or whatever. You don't have to use exactly these words, but you have to say something specific about Condorcet's method. All right? Any questions about that one? I'm going to, you'll have some chance to try these out on the homework. So I'm going to say the ranked choice voting will be on the homework. This is homework of next week. All right, so I'll leave it up to you to check that out on the homework. Let's talk about the Borda in our remaining 12 minutes. The Borda. All right. If we were trying to make the same argument with the Borda, you have to imagine one of our candidates is ranked on the top position more than 50% of the time. Does this mean that they will automatically win with the Borda? That is to say, does that mean they will automatically get more points than everybody else? Remember, the Borda is the one when you add up all the points. All right. Is that really true? If somebody is ranked in the top position by a majority, will they automatically get more points than everybody else? This, I would say, at least doesn't seem obvious to me. It seems like perhaps it's possible for somebody else who's like often ranked in second place to somehow, just when you do the math, they come out with more points. That seems like it might be possible. And in fact, that is possible. So I have an example. Borda actually does not satisfy this majority criterion. the majority winner criterion. Now, what does it take to show that it does not satisfy? What that means is actually it is possible for someone to be ranked first place by a majority and still lose the election when you add up all the points, all right? Actually, the way you have to demonstrate this, we do not write a proof in this example. We would just give a specific, we call it a counterexample. So a specific counterexample. That is to say, I need to make up, and this you would do, I mean, I'm just going to tell you, but you would, if you were doing this on your own, you would just have to kind of play around and try to create your own example. A specific counterexample where somebody gets the majority first place votes, but they do not win using the border. So I'll say, but they somebody gets a majority of first place votes but loses with the border. This is actually possible. If you think about, the border is like the same as the points in Mario Kart. And you can imagine, is it actually possible to win, get the most points at the end, even if you never came in first in any of the races? Actually, that is possible. If you come in second every time, and the other winners in each one are different every time, it is possible to actually win on points, even if you don't come in first all the time, right? And that can happen in the border also. So I'm going to give a specific example where somebody does get a majority first place votes, but they lose with the border. That is, the person who wins is someone who is in second a lot. So here is the example. It's not all that complicated. I have 3 voters said A, B, C, and 2 voters said B, C, A. That's it. And you can kind of see what's going to happen here. Okay, first of all, A actually is ranked in the first place by a majority, right? 3 versus 2. Put A in the top position. So here, A is ranked first by majority. But actually, when you add up the points, you'll see that A doesn't win. And the reason A doesn't win is because the other voters put A last, so A is going to get 0 points here, and B is going to get a lot of points. And when you add up the numbers, you'll see that B actually gets more than A. Can we add up the numbers? So the points go 0, 1, 2. And A's points are 3 times 2 plus 2 times 0. That is 6. All right. B's points is 3 times 1 plus 2 times 2. That's 3 plus 4, which is 7. So B wins here, and we should do C also, but C is kind of a chump in this one. 2 times 1, C gets 2 points, all right? So B wins with the border, even though a majority of the voters thought that A was the best. Yeah?
For the point section, why didn't you do 3, 2, 1? Why did you do 2, 1, 0?
The way the points in the border works, you always get 0 points for last place, and then it goes up from there. This is slightly confusing. Yeah, so the top position doesn't always get the same amount of points, even though the example I did at the beginning, the top position got 3, but it's always 0 for the bottom, and it goes up from there. All right, so B is the winner, even though A was ranked first place by a majority. So the conclusion is, so the border does not obey the majority winner criterion. So in this sense, border is worse than the plurality and the Condorcet. And the ranked choice, I'm going to leave it for you on the homework. Border does not obey the majority winner criterion. All right. So in this particular sense, the border is worse. Although, if you think about it, I don't know, how much should we care about this in terms of, in this particular way, the border is worse than the others. Because why is it worse? Because sometimes you can win on points, even if you didn't come in first place a lot. I don't really know if that's a real problem. Is that undemocratic? I don't know. Is it unfair? It doesn't strike me as all that unfair. So border does not obey the majority winner criterion, so it is, I would say, I'll put this in quotes, worse in this very specific sense Although I will leave it to you all to decide, like, does this really matter? Should we care that Borda doesn't satisfy this particular property? Like, it is true somebody can win on points even if they didn't come in first a lot. Does that, I don't know, that doesn't strike me as undemocratic necessarily. It's a little weird, I suppose, but I don't know if that really means that Borda is bad. But in this particular sense, the others satisfy, but the Borda doesn't. All right? There are, as I said before, there are many other ways we can try to evaluate these, and we could make sort of like a big, checklist or something. According to the majority, the plurality and the Condorcet are good, the Borda is bad. But there are other ways that we could evaluate these. There are many other criteria. And according to some of these other criteria, they actually think that the Borda is better than the other ones. It just depends. There are other ways that you could try to think about this. This one is very specifically about majorities, but there are other ways that we could evaluate them. And I thought, just to demonstrate this, like I said, when I taught this course in the past, we actually did 4 different criteria. I decided to cut it down, but I would like to just show you briefly. There's a very nice Wikipedia article that you can look at if you're interested in this sort of thing. Oh yeah, so it's called Comparison of Voting Rules. This is my iPad web browser, and it just occurred to me, like, I loaded this page up yesterday in preparation for showing it to you all today, but I was just thinking, have I been looking at other stuff in between yesterday and today? And I'm going to show everyone in class what I was looking at in my web browser. I didn't, though. Everything's fine. My My Little Pony fan site or whatever did not come up. Anyway, comparison of voting rules. There are, as I said, many different ways that you could try to evaluate and compare different voting rules with one another. And I would like to scroll down. There's a lot of fairly technical stuff here, but just to give you an idea, here we see a description of the majority criterion right here. There's actually 2 different variations. There's something called the majority loser criterion, which we're not going to discuss. There's the Condorcet winner criterion, which used to be on the list, but I changed it incorrectly. Anyway, I would like to breeze your eyes over this chart here. What we have here is these across the top are various different criteria that you could use to judge one of these systems. Here, the very first one is what we just talked about, the majority winner criterion. And you will see, actually, there are many more columns here. Like, these are all the different ways that people have talked about trying to evaluate these systems. There are many different criterions. And the different methods, there are also many different methods here, right? You can see, so right here is instant runoff. That's what we've been calling ranked choice voting. There's other ones, the Coombs. Anybody into the Coombs? No. I kind of like the Coombs, but we're not going to get into that kind of stuff. Down here, there's Borda. There's the Borda, right? And you can see Borda, majority, no. That's what we just discussed. This means in the Borda, it is possible for sort of like a strong second place person to actually win, even if there was someone who had ranked first by a majority. But you can see these other things, actually Borda has a yes in them. So it's not that Borda is just like totally stupid. In that one specific way of evaluating, Borda comes up worse than the others, but there are other methods that do work. This ranked pairs, that's what we call the Condorcet method, and you can see actually that gets a lot of yeses. That means that method is sort of like super awesome. Of course, there's the big problem that it doesn't always choose a winner, all right? And in here, you can see somewhere in here is the plurality. Oh yeah, plurality is also known as first past the post. In politics, they often call it that. Anyway, they say yes, that's what we discussed. So I'm just trying to give you an idea here about the huge breadth of like research that has been done about these various things. We in our class are only going to talk about a very small, we're really only talking about the first column in this giant chart and only 4 of the rows, not all of these rows like that. All right, I just wanted to impress you with the big chart. We'll talk about something else next time.